So as we previously mentioned, we're going to be performing a number of different titration calculations, but the big thing that you need to have in the back of your mind is that the equivalence point is always going to be when the moles of hydronium ion from our acid, when our moles of hydronium ions from our acid is equal to the moles of hydroxide ions from the base. So our equivalence point is going to be when those two amounts are equal to each other. So let's take a look at our first type of calculation where we're going to determine the concentration of a solution. So in this example, we have a 25.0 ml sample of sulfuric acid, and it's 46.23 mils of that is required of a standard solution of 0.203 molar sodium hydroxide to reach the equivalent point. So calculate the concentration of the sulfuric acid. So the first thing that we're going to be doing is determining the number of moles of our standard solution, which in this case is the sodium hydroxide. So as I mentioned in the previous video, instead of working in moles per liter, we're going to often work with millimoles per milliliter, so we're not having to convert our volume to liters every single time. And so reminder, moles per liter is our concentration. If I just divide each of those values by 1,000, then a mole divided by 1,000 will be a millimole, and a liter divided by 1,000 will be a milliliter. So millimoles per milliliter is the same thing as moles per liter. Okay, so I've set up my reaction. It's important to note here that sulfuric acid is diprotic, so I'm actually going to need 2 moles of sodium hydroxide to neutralize 1 mole of sulfuric acid. So first I want to figure out my millimoles of my standard, which in this case is sodium hydroxide. So millimoles of sodium hydroxide is going to equal the volume, which was 46.23 mils, multiplied by the concentration. And so I'm going to write the concentration in millimoles per milliliter so that I don't have to be converting my volume to liters every time. Okay, so that's going to work out to being 9.385 millimoles of sodium hydroxide. Now, next I want to figure out my number of millimoles of my analyte, which is the sulfuric acid, the thing I'm trying to find the concentration of. And so I know that if I have 9.385 millimoles of sodium hydroxide, and here's where my mole ratio is going to come in, 2 moles of sodium hydroxide are required to neutralize 1 mole of sulfuric acid, H2SO4. Okay, so that's 4.692 millimoles of sulfuric acid. And then finally, if I want to figure out the concentration of the sulfuric acid, I need to divide that by the volume that that amount of millimoles was in. So it was in a 25 ml sample. So I'm going to take 4.692 millimoles divided by 25.0 milliliters, and that turns out to being 0.188 molar.